Hello everyone, welcome to Math Archives. This is Subhashini Vijayasekaran, a Maths teacher. In this video, we have to discuss about arithmetic mean. It is one of the most popular and widely used measure of representing the entire data by one value. Also, A dot M is the abbreviation used for represent an arithmetic mean, and also X bar is the symbol which is used to represent an arithmetic mean. Now, let's calculate the arithmetic mean for individual series, discrete series or ungrouped frequency distribution, continuous series or grouped frequency distribution. Let's now first discuss about the arithmetic mean for individual series. That is the formula used for calculating the arithmetic mean when individual observations are given as x bar is equal to sigma I varies from 1 to n xi over n. This is the formula used to calculate the arithmetic mean when the individual observations are given. Here x bar represents, that is the symbol used to represent an arithmetic mean, and capital N here represents the total number of observations. How many number of observations are given, that is represented by capital N. The next sigma I varies from 1 to n xi. That is nothing but that represents sum of all values of the observations. So using this formula, we calculate the arithmetic mean when individual observations are given. Let's now calculate the arithmetic mean for individual observations. Here the data are given in terms of individual observations. So we make use of the formula for calculating arithmetic mean as x bar is equal to sigma I varies from 1 to n xi over n. So here total number of observation here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So totally we are having 12 observations. So when I is equal to 1, we have x1. When I is equal to 2, we have x2 plus etc. up to when I is equal to 12, we have x12. So here x1 is nothing but R80, x2 is 88 and our x3 is 92. Like that we have to add all the values. So now let's add all the values. 80 plus 88 plus 92 plus 84 plus 96 plus 92 plus 96 plus 100 plus 92 plus 94 plus 98 plus 86 over 12. Now let's add all these values. Adding all these values, we get 80 plus 88 plus 92 plus 84 plus 96 plus 92 plus 96 plus 100 plus 92 plus 94 plus 98 plus 86. So we get the total of 1098. So x bar is equal to 1098 divided by 12. When we divide 1098 by 12, we have 91.5. So x bar is equal to 91.5. That is arithmetic mean for the given set of observation is 91.5. Let's now discuss about how to calculate arithmetic mean for discrete series or ungrouped frequency distribution. The formula used to calculate arithmetic mean for ungrouped frequency distribution is x bar is equal to sigma fi xi over n. Here f represents frequency. Frequency is nothing but the number of times the values observed is called that frequency. And also x represents the variable that is given in our question, and capital N represents total number of observation, that is sigma f, sum of the frequencies. Let's now calculate the arithmetic mean of marks obtained by 60 students of a class given below. Here the marks and number of students are given. 20, 30, 40, 50, 60 and 70 are the marks given for the students. The number of students scored 20 marks as 8. The number of students scored 30 marks as there are 12 students. The number of students scored 40 marks as 20 students, like that. Here we assign the variable x is nothing but marks and the number of students as a frequency. Let's now assume x represents the marks and f represents number of students. Now let's now construct a table to calculate the arithmetic mean, because we know the formula for calculating the arithmetic mean for discrete series is x bar is equal to sigma fi xi over n. For this we need the product of the frequencies with the variable. So as I told you earlier, we have to take the marks as a variable x and we have to assign the number of students as the frequency. So let's construct a table whereas the first column consists of marks, that is nothing but the variable x, and the second column consists of number of students, that is nothing but our frequency f, whereas the third column is the product of f with x, that is fx. Let's now write down the given values in the first and second column. The marks are given as 20, 30, 40, 50, 60 and 70. Corresponding frequencies are 8, 12, 20, 10, 6 and 4. And now let's now multiply. Fx is nothing but you have to multiply the frequency with the variable f with x, that is 20 into 8. So 20 into 8 is 160. Like that, 30 into 12. 30 into 12 is 360. 40 into 20. 40 into 20, 40 is multiplied with 20, we get 800. 50 into 10, when 50 is multiplied with 10, we have 500. When we multiply 60 with 6, we have 360. And we multiply 70 with 4, we have 280. So since they are very small in number, so let's multiply manually. Now let's now calculate the arithmetic mean. For that we need the total of sum of all the values of fx, that is sigma fx and also n. Here n is nothing but sigma f. N is nothing but sigma f, that is sum of all the values of the frequencies. So let me add all the values of f first. We add all the values of f, that is 8 plus 12 plus 20 plus 10 plus 6 plus 4 we have 60. By adding the values of fx, we have 160 plus 360 plus 800 plus 500 plus 360 plus 280. We have 2460. So we have got the two values, that is sigma Fi is 2460 and n is 60. So by dividing 2460 over 60, we have 41. So x bar is equal to 41. That is arithmetic mean for the given set of ungrouped frequency distribution is 41. Let's now discuss about how to calculate the arithmetic mean for continuous series or grouped frequency distribution. The formula used to calculate the arithmetic mean when the data are given in terms of continuous series is x bar is equal to sigma Fi mi over n. As usual, here f represents the frequency of each class interval and m represents the mid value of each class interval. M represents the mid value and n is the sum of all frequencies, that is the total number of observations. That is, now calculate the arithmetic mean for the given set of data. Marks and number of students are given. Look at here. Here the marks are given in terms of class intervals. That is, these are given in terms of grouped frequency distribution. That is, there are 8 students. Those who are getting marks from 0 to 10 is only 8. That is, there are 12 students. Those who are getting marks from 10 to 20. And 20 students marks are from 20 to 30. And there are only 6 students. Those who are getting marks from 30 to 40 and 4 of them are getting marks from 40 to 50. The formula used to calculate the arithmetic mean for continuous series or grouped frequency distribution is x bar is equal to sigma Fi mi over n. Here n represents sum of the frequencies, that is sigma f. And m represents the mid value of each class interval and Fi is the frequency of each class interval. That is the correct. Let's now construct a table consists of 4 columns, whereas the first column represents the marks of students, and the second column represents number of students, and the third and fourth column represents the mid value of each class interval, and we need the product of Fm. For that only we can construct this table now. Let's now assign the marks as a variable x and number of students as a frequency f. Marks is assigning a variable x and we assign the frequency as number of students. And the first class interval here is 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. The corresponding frequencies, that is number of students given in the problem as 8, 12, 20, 6 and 4. M is nothing but the mid value of each class interval. That is, for the class interval 0 to 10, mid value is obtained. That is, how to calculate the mid value of each class interval is, mid value is nothing but lower limit of the class interval plus upper limit of the class interval over 2 gives you the mid value of each class interval. For the class interval 0 and 10, 0 is the lower limit and 10 is the upper limit. While we are adding 0 with 10 and divide it by 2, we have 10 by 2 is nothing but 5. So 5 is the mid value of the class interval 0 to 10. Like that for the second class interval 10 to 20, while we are adding 10 with 20, we have 30. 30 by 2 is nothing but 15. And for the next 25, 35 and 45. So to calculate the arithmetic mean, we need the product of f with m. That is, we have to multiply frequencies with the mid values of each class interval. Multiply 8 with 5. 8 into 5. 8 5s are 40. Multiply 12 with 15, we have 180. Then 20 into 25. We have 500. Six into 35. 210. 4 into 45. 180. Adding all these values, we get sigma fm. Like that, while adding all values of f, we have n, that is nothing but sigma f. 8 plus 12 plus 20 plus 6 plus 4. We have the total as 50. So sum of the frequencies n is something but 50. And adding, now add all the values of fm. 40 plus 180 plus 500 plus 210 plus 180. So we have the total of 110. Triple one, sorry. We have a total of 1110. So x bar is equal to 1110 over 50. That is, when we divide this by 50, we have 22.2. So x bar is equal to 22.2. So the arithmetic mean for the given grouped frequency distributions is 22.2. Let's now discuss one more problem under this category. Calculate the arithmetic mean. Here the marks and number of students are given. Marks are 0 to 19, 20 to 39. Look at here, the class intervals are not continuous. Unlike the previous type, here the class intervals are not continuous. That means that is, the upper limit of this first class interval is not the lower limit of the next class interval. That is, there is a gap here. So that means there is no change in the procedure. That is, we make use of the same formula for calculating the arithmetic mean for this type of class intervals too. So the class interval like this is nothing but inclusive class intervals. That is, the class intervals are not continuous in this type. the only difference, that is the only difference. So we make use of the same formula, that is x bar is equal to sigma fi mi over n. Here f represents the frequency, m represents mid value and n represents total number of observations or sum of the frequencies. For that, let's now construct a table consists of 4 columns, whereas the first column consists of marks. And the second column represents number of students. And the next column is nothing but our mid value. And the last column is nothing but product of f with m. For that, before that, let's assign a variable. We assign the marks as the variable f and the frequencies as f. So the first column represents the variable x and the second column represents the frequency, and the mid values are always represented by m, and the product of f with m is nothing but fm. Now let's write down the values given for marks. Now let's write down the values given as marks as in the first column. The number of students are 5, 17, 32, 24 and 12. Mid values. Mid value, as I told you already, mid value is calculated by adding both lower limit and upper limit of the class interval, and we divide this by 2. That is 19 divided by 2 is nothing but 9.5. And then for the next class interval, we add 20 with 39 and divide this by 2. When we add and divide this by 2, we have, and for the next class interval, 40 plus 59 over 2, we have 49.5. And for the next class interval, 60 plus 79 over 2, we have 69.5. And for the next class interval, 80 plus 99 over 2, we have 89.5. So these are all the mid values of the class intervals given in our problem. Now let's multiply the frequencies with the corresponding mid value. When we multiply 5 with 9.5, we have 47.5. Next, when we multiply 17 with 29.5, we have 501.5, and when we multiply 32 with 49.5, so we have 1584. When we multiply 24 with 69.5, we have 1668, and when we multiply 12 with 89.5. We have 1074. Now let's add all the frequencies and all the values of f with them. That is Fm. That is here n is nothing but sigma f. Now adding all the values of f, we have 5 plus 17 plus 32 plus 24 plus 12. We have a total of 90. Like that we add all values of Fm. 47.5 plus 501.5 plus 1584 plus 1668 plus 1074. We get the total as 4875. So our sigma Fm is 4875. And when we divide 4875 divided by 90, that is sum of the frequencies, we have the total as 54.166, that is 54.17. So x bar is equal to sigma Fm over n. Sigma Fm is nothing but 4875 and we get the value of n as 90. When we divide 4875 over 90, we have 54.17. So the arithmetic mean for the given set of observation is 54.17. Thus, hope you got a clear idea about how to calculate arithmetic mean for integer series, discrete series or continuous series. Thanks for watching. See you again in my next video.